Hello and welcome to this Modular monthly series of videos from Future Music magazine, this time looking at the Pittsburgh Modular Lifeforms Mod Tools. Let's check out what's to come before we get into it. Now, the Mod Tools is a series of modular tools, and utilities and basic functions are really what separates a modular system from a more standard hardware or even software synth for the most part. Going from bottom to top, we have this modulation section, which is an LFO with basic control over rate and a square and a sine wave output. We then have a noise, which has its own output, which is great for audio or modulating other things, and then a sample and hold circuit with input to sample, which is the noise by default, the hold and the actual output itself. We then have an analog logic section, which gives us two inputs, and an OR, which is the maximum voltage between the two inputs, and a mixed output, mixing those two ins. We then have the multifunction, which is a function generator that can be an envelope, an LFO, it will loop with the flick of a switch. We can use this with sustain on or off, so it will either be triggered behavior or gated behavior. It can also be a slew, it can be an oscillator, and we've got CV over the length, those rates of the rise and fall controls. So let's get into a few different patches and see why the Mod Tools offers us a ton of exciting, useful things for a modular system. So here's a stereo patch that is a saw wave into a quad filter, two filters per side, hard panned left and right, and some basic effects. And I'll just sweep this filter. And going to each side of the filter's modulation for the cutoff modulation are the two outputs on the analog logic section. And by default, the LFO and the function generator, and here the function generator is set to loop. We can see that on this LED, showing us that this is in the LFO mode. These are normalized to the two inputs of the logic, and we get an OR output and a mix output. Now, the OR output will take the maximum voltage between the two. So if the LFO is at its positive peak, but the function generator's voltage is lower, it will use that one. And then if the LFO comes back down and the function generator's voltage goes higher, it will take that one. And here's what the OR output looks like. It's the highest voltage between the two inputs. Now the mix output, which is going to modulate the right hand side of this filter, is the blue trace there on data. So I'll play around with the function generator and the LFO and see how we can influence this modulation. And I'm just going to raise the cutoff on the filter before I do that. You can see on that blue trace a really nice mix of this faster function generator and the LFO, and then the maximum voltage between the two on the green trace. For more complex behavior, we can start to cross-patch them and get some feedback patching and just some more interesting complex modulation. So I've zoomed the camera out for this particular patch so you can see everything that's going on. I have a beat that's sequenced, well, outside of this camera angle, but that is the input to the scope, and we're currently listening to it on this grey cable. This is what's feeding my output. Some more quirky electronic drum sounds, but a rather basic beat. Now by patching that across as the input to the sample and hold stage, and using an audio rate oscillator, which is just a square wave out of this endorphins oscillator, we can clock the sample and hold at audio rates and get a downsampler effect. So sample and hold output to my recorder. And the rate of this oscillator is what determines this downsampling. So as I turn it down, much lower sample rates. Well, not really sample rates, we're kind of mimicking what sample rate is in an analog domain. Bringing that rate up. It works particularly well for this quirky electronic beat, giving us this nice kind of aliased downsampled top end. So in this patch, I'm exploring the sample and hold and also creating a random gate. Now, let's forget about the random gate for a second. The green trace is the sample and hold output. By default, the noise source feeds the input, and the square output of this LFO feeds the holding. And sample and hold, sampling a random voltage from noise, and analog noise is a random source, we get random stepped modulation. Now this is modulating the wave shape of an oscillator. And by patching this same sample and hold signal, I'm just splitting what you're seeing into the input of the function generator, and then taking the output of the function generator, first to the scope, and then to a kick drum. Little patch making a kick drum sound. That's this shape. Now sustain is off, this is set to envelope mode, and when the voltage from the sample and hold is high enough, it triggers this shape, which is rise all the way down, and I guess a moderate fall amount. And we get an in time random gate. It will follow the rate of this sample and hold. And notice that these fire, as I said, when the sample and hold voltage is high enough. Back in with the sample and hold signal. So that's how to patch up a random gate, or rather a random envelope out of the function generator, and some random sample and hold. Now if we want to smooth out this sample and hold, we can do that by using the function generator again. So I've repatched this time. The sample and hold signal is on the scope, but it's coming straight into the function generator, giving us this random gate from the previous part of the patch. I'll just mute it for now. That was affecting the kick drum before. This is now what's modulating the wave shape on my oscillator. But if I flick the function generator's sustain mode on, turn these times down, this becomes a slew limiter, and we can think of slew as glide or lag or portamento. And when we're playing pitch on a keyboard, for example, we turn up portamento and the notes glide between each other rather than step on and off with each different key press. And that's what we're going to do here for this random voltage. I've just adjusted the scope there, and the blue trace is the output now of the function generator. And this is separate slew time. So if I add some rise time, rising voltages are actually slewing up, turning rise down, turning fall up. Notice the voltages that are falling are gliding, and with both of them up, we've smoothed out that stepped modulation. And we can think of this as fluctuating random or smooth random. So you get hard stepped sample and hold, random, when we sample the noise source. We can patch that into the function generator with sustain off to create random envelopes. We can have sustain on to smooth the random, meaning that mod tools can really give us 3 different types of random. So to finish on, this patch makes use of each section of the Lifeforms Mod Tools. The LFO sine wave out is controlling the PWM on this further generator oscillator. That square wave or pulse wave that has its modulation from Mod Tools is going into the stereo dipole, but it's just a simple, basic, non-resonant low-pass filter. The function generator is what's modulating the cutoff of that low-pass filter, and the actual function generator's length, the time of rise and fall, is modulated by the onboard sample and hold. I'm taking the noise output into a VCA and using the mixed output from the analog section, which mixes the function generator and LFO, to let this VCA let some noise through. That's coming into my oscillator, giving us a nice fuzziness. If I turn that up, you can hear that noise imparting its tone in the oscillator, its frequency modulating the oscillator. But backing that off, And the OR output of the analog logic section, which is the yellow trace on data, if you can see that within the screen, is going up to modulate the sustain, the decay of my reverb. So when the function generator and the LFO are producing lower signals with a much shorter reverb. So all that expression and modulation, everything except the pitch sequence, is coming from Mod Tools. For more videos, check out the Modular monthly playlist of videos here on the Future Music Magazine YouTube channel. And thanks for watching. See you next time.